Hello students, so we were done already with our discussion on how to convert decimal and binary and vice versa. So today our discussion will focus on octal and hexadecimal, and also how to convert octal, hexadecimal, and all together with binary and decimal. For now, we're going to discuss first the octal and binary and hexadecimal. Okay. So we know that octal consists of 8 digits from 0 to 7. Okay, so after number 7 we increment by 1, so 1, then 0 up to 17, then increment this second digit, so 20 to 28. Okay, for hexadecimal it consists of 16 digits, okay, with letters also. So it consists of 0 to 9, and then after 9 you have the letter A, B, C, D, E, and F. So if you're going to convert this to decimal number, letter A is equal to 10, B 11, C 12, D 13, E 14, and F is 15. An example of an octal number, say 57, and then we put the subscript number of 8. Okay, 0, 5, 7, and then we put the subscript of 8. For hexadecimal naman, you can put 1 AF, and then put the number 16. So we will know that this is a hexadecimal and this one is octal. So we go to the conversion of these numbers. Okay, so if we're going to convert octal to decimal and hexa to decimal as well, we need to go through the binary equivalent first. Equivalent. Okay, for us to do the simple way on how to convert these numbers. Okay, so say for example we have the octal number of 57. Okay, so in order for us to convert this number to decimal, we need to convert it first to binary. So how are we going to convert it to binary? So we're going to split it into 2 digits, 5 and 7. So we need to get the binary equivalent of this 7 and then 5. Okay, so we know already the value of the positional notation of binary, which is 1, 2, 4, 8, and so on. Okay, so for 7 we have this one, 4 plus 2 plus 1 is 7, so 1, 1, 1. And for number 5, so we have this 4 plus 1. So we get 1, 0, 1. Okay, so we read it as 1, 0, 1, 1, 1, 1. So this is the equivalent of the octal number 57. Okay, and then from binary we can now convert it to decimal. So you have the binary number of 101 111. So if we're going to convert it to decimal, so this is the values for the positional notation: 1 2 4 8 16 32. So we cross out this part because the binary number is 0. So all we have to do is to add 32, 8, 4, 2, and 1. So the answer is 47. Okay, so from the octal number of 57, we get the value of its binary equivalent, which is 101111, and then from binary we get its equivalent of 47 for decimal. And because in octal, if the given number is binary, we need to group it into 3, counting from the right side, rightmost number. So this one. Yeah. Because the positional notation of this number is equal to the octal digit. So 1, 2, 4, which is 4 plus 2 plus 1 is 7. Okay, the last digit of the octal is 7. And this is another digit for octal. So this is 5 and this is 7. For hexadecimal, so say for example we have the example 1 AF. So how are we going to convert it to decimal? Okay, so all we have to do is to convert it first to binary. So each digit for this hexadecimal number, we have to get the binary equivalent. So 1, A, and F. So we know that hexadecimal, letter F is equal to decimal number of 15. Okay, so if we're going to put it in the binary equivalent, so we have 4 ones. Okay, A is equal to 10. So positional notation 1, 2, 4, 8. So we have 8 plus 2, which is 10. So we have the number 1010. So that is equal to 10. And then 1 is equal to 0001. Okay, because in hexadecimal, if we're going to write it in binary, it is grouped into 4 digits, because 4 digits is equal to 15. Am I right? So 8 plus 4 is 12, 13, 14, 15. So this is 15. So that is why this one, itong F, ang equivalent niya is 4 ones. So if we're going to write it, so 0, 0, 0, 1, 1, 0, 1, 0, and then 1, 1, 1, 1. Apat na 1. Yan. Okay? There is no spaces. There are no spaces in between pag andito na siya pag sinulat na siya as binary numbers. Okay? So, from binary number, that's the time that we can convert it to decimal. Okay? So, from this one, ito na siya. So, paano? How are we going to convert it? By placing positional notation. Okay? So, this is binary pa rin na 1, 2, 4, 8. Tama? 16, 32, 64, 128. Okay, ito yung mas klaro. Okay, positional notation. 1, 2, 4, 8. 16, 32, 64, 128, and this is 256. Okay? 256. So, lahat ng may 0, i-cross out. So, this one and this one. So, we're going to add 256 plus 128 plus 32 plus 8 plus 4 plus 2 plus 1. Okay? If you're going to add these numbers, so we get 431. So this is the decimal equivalent of the hexadecimal number 1AF. Okay? So I hope that you get how to convert these numbers from one number system to another. If the given number is in binary form, okay, so if we're going to convert it to octal, we need to group it by threes. Okay, threes. For hexadecimal naman, we need to group it by fours, starting from the rightmost number. Okay, so say for example, we have the numbered binary number 1101100101. Yan. If we're going to convert it to octal, we have to group it by 3. Okay? So, sabi ko kanina, from the rightmost number, 1, 2, 3. So, ito siya. Yan. And then, 1, 2, 3. Yan. Okay? So, this is still your first digit, second, and then third. If we're going to convert it to octal. So, the same number, 110110101, if we're going to convert it to hexadecimal, so we need it to be grouped to fours. So from the rightmost digit, 1, 2, 3, 4. So ito siya, 1, 2, 3, 4. Okay. So if you can see here, nag-iisa lang siyang digit. So automatic, the rest of the numbers here are zeros. Okay? So compute this one, that would be your first digit here. This one, compute separately, that would be your value here. And then compute separately, that would be your value in this place. Okay? if we're going to get the equivalent for this binary number, so we know already the positional notation: 1 2 4 1 2 4 1 2 4. So this is 5. 4 plus 2 is 6, and 6 as well. Okay, for hexadecimal number, so this is 1 2 4 8, 1 2 4 8, and then 1. So for this part, 4 plus 1 is 5, 8 plus 2 is 10, plus 1 is 11. So what is 11? Letter B. Ayun siya, letter B. And then the last group, which is 1. Yan. So this is an example of binary numbers, of the same binary numbers, but they are converted to what? This is hexadecimal, octal I mean, and this is the hexadecimal number. Okay, so I hope that you get the correct way of converting these numbers. So for now, we're going to have an activity on how to convert a number system from one number system to another. So all you have to do is to comment down your answers. Okay, decimal, binary, octal, and hexadecimal. Two, three, four. Okay. So you have to answer. Say for example, I have here 132 for decimal. So you need to get the binary, octal, and hexadecimal equivalent. So if we have the binary, one one zero 10101, for octal 457, hexadecimal 2BF. Okay, I need to put another line, another box, another row. Dito tayo sa octal. 1 5 8. Okay, so comment down your answers. Okay, thank you very much. I'll just wait for your answers. Thank you.